third-year structural engineering major. They're both completing their undergraduate degree at University of California, San Diego. Wastelights Engineering is a startup team at UCSD that is part of the Basement Entrepreneurial Program that develops sustainable projects to convert waste into electricity. Wastelights already has a prototype in Nigeria and plan to develop their prototype further and bring it to the product market soon. Please welcome Wastelights Engineering.
Hi everybody, good afternoon. My name is Ashti Talwar and
hello, my name is Gurunath Nasaraja.
Yeah, so I've also, just before starting, I just want to thank SDSU associated students and the PowerSafe program for inviting us over. And also Peter Myson, because I worked over the summer with him, Global Classroom Project. If you guys really love renewable energy or want to do something about it, great place to work. You can really start off your career. And that's how I kind of got involved in Wastelights myself. All right, without further ado, Wastelights. Yeah. So what is Wastelights? Wastelights basically is an idea, or rather, we co-founded this company at UCSD, and we are all a different, set of engineers involved. As you can see, our 4 members here. I'm an electrical engineer, Guru structural. Other 2 members are mechanical, nanotechnology. But we all share one goal in common, which is that we were very passionate about renewable energy, so we started Wastelights. All right. So Wastelights is an environmentally conscious energy company that aims to solve the problem that most developing nations today face. Abundance of waste, but a lack of electricity. And how we do that is convert food waste, sewage, kitchen waste, and other kinds of waste into electricity.
So how does this work? So Wastelights Engineering, within this past year, has developed several methods to be able to convert all this waste into energy. And our main method that we've been working on this past year is called a biodigester. Essentially, a biodigester consists of we put in all this waste into a digester, and it becomes churned out through the process of anaerobic digestion. And with anaerobic digestion, it breaks down the waste and converts it into the form of methane gas. As we have our biodigester bin, we connect it to a series of tubes, valves, into a rubber tire where the methane gas flows into the tire. Are connected to our methane gas generator to produce the electricity.
All right. So as Guru just explained, that the biodigester is an essential component of our product, but also we have other important components in this product. For example, storage systems, and these are referring to electric storage systems. So not everybody, we wouldn't just need to keep producing electricity throughout the day, because once nighttime comes, you don't need to use the same amount of electricity as you use in the day. So that's why we built a storage system that allows us to use electricity at will and save up that electricity through rechargeable batteries or lithium-ion batteries, and then we can use them the way we feel like. Also, another important component is microcontrollers and sensors. This helps us to analyze our data, record temperature and pressure readings, and understand how the methane is flowing through it to see if our system is producing accurate results or something's broken inside. Also, another important thing is the electric circuitry. So we're not building the system just to power, basic light bulb. We're trying to work with more complex systems such as houses, electrical grids of countries. And lastly, another important component is the gas generator. Currently, we're using, it's not our own design gas generator. We're using gas generators that have been previously built. But we're trying to break down the gas generator and reduce the cost of it and build our own one, which involves less materials and is more efficient in terms of producing electricity.
So Ashri just detailed a lot of the smaller components that goes into this biodigester and what we've been making for the past year. Being a structural engineer, I'm in charge of the product design of the entire system. So you think it's just the outward appearance, but no, there's more to it. There's a lot of calculation with designing the system, especially with the units. We use AutoCAD, SolidWorks, and SAP to help make the design and model for this biodigester. And one thing about it is that we researched a ton of materials, what we could use to help make this product more efficient, cheap, and also see what works best that allows our methane gas to flow through the system and convert that into electricity.
All right. So target market. Who is our target market? So our primary target markets are homes, farmers, and we also have NGOs, government entities, and off-grid communities. Now, why homes and farmers? We could have just built this and gone straight up to the utilities and you said we can connect to the grid and be done. That's not the challenge. The important part is that homes and farmers produce their own waste. Homes produce regular kitchen waste, which is food, and farmers have a lot of agricultural land, so they have animal cattle, which gives them animal waste and plant waste, and that means that it's a zero input to the system. So they don't even need to pay for any of the inputs. They have them at home. So they just set their unit up and produce electricity of their own. It benefits them. And at the same time, in developing nations, homes and farmers don't even have access to electricity at a constant rate. Transmission line cables don't even reach them, even though the grid is right there. And they also do pay for this electricity, but they don't even get the use of it. So this is where we kind of target it. And the way we kind of enter these markets is through government entities, because we cannot expect, the lower middle class people or even the lowest class to pay for this technology up front. So the government will help subsidize our, production costs and open up a factory, and we can locally manufacture all the parts there. And lastly, non-profit organizations help us out greatly. We worked with recently the Compassion of African Villages, and they help us better understand the locality of the region. For example, I'm from India myself, New Delhi, and I've seen how homes are. So what we had is, I think, not Guru, our other two co-founders who are not here right now, went to Zimbabwe actually, and saw how people live there, and what kind of appliances they use, how do they get electricity, how much do they need, things like that basically. And that's how non-profit organizations help us out.
So basically, one of our main goals, obviously, is to get rid of waste. Now, our competitors, there's a lot of other ways they could get rid of waste, which we could briefly go over, like landfilling, composting, getting rid of our waste, but you're trashing that away into valuable land that we'd be using for construction and all other sorts of things. Landfilling also, it just pollutes the environment, intoxicates the ozone layer, greenhouse gases emitted, burning the environment, and essentially, it's just not a great way to get rid of our waste. And also, other competitors like solar, wind, hydro, and tidal companies, like those are also very effective. However, they're limited by location, weather, and also, they're also very expensive to utilize as well. So, for example, solar companies, right? It works out well during the day, but at night you're not producing any energy, any electricity. Wind turbines, pretty much those can only be effective when they're offshore or in the Midwest when wind pressures are very high. However, like with Wastelights, we produce a system that is also very cheap, light, portable, easy to use, and also it's a two-way street when it comes to individuals being able to take the initiative of not only being able to get rid of their waste, but effectively convert their waste into electricity. So you're getting rid of waste and you're producing electricity.
Alright, here are the list of our accomplishments so far that we've achieved. Last year we were third place at the Zane Prize competition, we were semi-finalists at the UCSD Entrepreneur Challenge, as well as the Research Pitch competition. Also, just recently we've been admitted to the new startup incubator, which is known as the Basement. And we're also, at the end of summer 2016, working with the Honduras government to implement our third and fourth prototypes. And lastly, we've also been part of the NSF I-Course program, and recently completed phase 2, which has given us a great amount of funding in order to help develop our business further. So I've talked about the present and the past of Wastelights, but now what about the future? So our future plans are, one of them is to continue filing patents. The second one is to develop the business model further by gaining, mentors and guidance. Mentors, guidance, and funding. And we plan to use the UCSD Rady School of Business professors there to help us expand our model further and enter into different nations and target a more global market. We also plan to market the company further on through Facebook, social media, and also professional networking sites. And lastly, we plan to do a Kickstarter by the end of this year. And we aim to raise capital from that and help expand our business and also build up these large-scale systems, because currently we're just working on small-scale systems that can satisfy maybe 20, 30 people in a village, but we want to build a much larger system that can satisfy maybe the entire country.
The production of this system has been very successful in the past year because a lot of engineers like myself and scientists have put in so much research into being able to allow this to happen. So we've partnered up very well with a lot of other engineering organizations to assist us, including Engineers for a Sustainable World. and also gotten recognition from the National Science Foundation to assist us and fund us as well. And we've also been given international acclaim to work with Finland, the United Kingdom, and towards the end of summer of 2016, we'll be traveling over to Honduras to also produce the system as well. And other than that, that'll be it actually. Thank you. Do you guys have any questions?
How far into your undergrad did you develop the model that you're like, hey, this is what I want to do, and
Well, I came in starting as an engineer. I mean, this is my personal look. Who would have a different opinion? So I came in there and I started off electrical engineering. I didn't even know like the A, B, C of electrical engineering. I just knew I wanted to do engineering. But then later on, once I progressed in my first year, I just saw that, what I'm doing is not helping me as such. And I've just gone on job fairs, everybody turns me down. But then I realized that, this is not going to interest me. How am I making a difference in the world? Or what can I do different from other people? Because I don't want to just be the same person, 8 to 5 work every day. That's not me personally. So then in my second year, and I started realizing that I want to do something more. And actually, and then I actually got introduced to one of our other co-founders who was into this thing. And she built the first prototype in Nigeria. So she told me, you look like you're interested in all renewable energy. And my specialization now is power electronics, power engineering. So then I got really interested in this, and we started off from them. And starting my third year, it's just been good, ups and ups. But also we've had really bad downsides. So we've messed up a couple of competitions, we've lost a lot of opportunities. But that's the part of learning. I think life is all about good experiences. So for me, my third year really helped me out. And then I worked with Genie over the summer. So then my interest started growing even further. So now I'm already specialized, and now I've decided, I'm going to build this company and this idea and take it up to the next level. The journey is going to be really hard, but I look forward to it definitely. So that's at least my story.
I've always been interested in sustainability since like around the 10th grade in high school actually. We have a lot of Go Green projects that we worked on, and that was part of the environmental club. So that really got me going and always thinking about the environment, how I can contribute to really be helpful in society. And I was also approached to help my friend with the system. Actually, I was approached by Joyce, who is another one of our founders, who came up to me and asked if I could help her out with the system. And I've been more invested into the project since the start of last school year.
And also, I'm from India personally, so I'm an international student, and I'm from New Delhi. And like Peter said, if you go outside the main city, it's just tons of waste. People are literally just sleeping on that waste, and they don't even have basic needs that we take for granted here. So that really got me motivated, and I decided, I'm going to go back to my country, implement the same technology, and make sure at least everybody can reach 2,000 kilowatt hours per capita and just have a basic life. Because you feel good when you do it for. Obviously it's a start of a profit, but you really want to make a change in the world. And there's so many ways, renewable energy it's a growing field. So if you pick up anything and you see the interest, there's so many gaps that are still being explored. So solar energy's got lithium-ion batteries, the materials and all out there, but there's so much research just in solar or even in the other technologies that you could definitely find something, pick up, and apply it to yourselves. Or when you see a daily problem, you might be able to help you or whoever the person next to you is,
Yeah. In your first or second slide, I saw the word nanotechnology. How are you guys using nanotechnology, and what for?
Well, the nanotechnology guy actually isn't here, but
Who's that?
the nanotechnology guy is not here. Someone, he's the other one who's working on nanotechnology.
Oh.
So he's using more of the materials and engineering science there, devices and materials, to help build up our components with cheaper materials. So we don't classically use all that. So that's where the nano part's coming in. The depth is also devices and materials.
I don't know why you guys. I walk in when you guys had that slide. I done a lot of research actually on nanotechnology, and I used to be pro nanotechnology, but since I have kind of changed my mind because I know about the negative effect, environmental impacts of it. So I was just wondering how would that in your world will be sustainable.
No, we're just
So
looking
you
at.
guys, okay.
No, we're just looking at material costs and that, not pro. We're more of like chemical engineering. This is more of
Okay.
chemical process.